Alright, so if you missed today's lesson, we covered 10.7 and 10.8. First we started with trying to find the area of segments. And before we did that, we started with this warm-up. Find the area of the sector shaded in. We also have to remember that the sector area is equal to the measurement of the arc over 360 times the area of the entire circle, pi times radius squared. So let's look at this. The arc of the shaded sector would be right here, right? And we want to know what is that angle. If we know that this angle right here is 120 and that this angle combines with 120 to make a straight line, 180, then we can find that the measurement of the arc is equal to 180 minus 120, which equals 60 degrees. Next, the radius of the circle is equal to half of the entire diameter. So the diameter is 26. Divide that by 2. You get a radius of 13. Next, the sector area is equal to the arc, measurement of the arc, over 360 times pi times the radius squared. The measurement of the arc is 60 divided by 360 times pi times the radius of 13 squared. And what I showed you guys before was that you multiply 60 divided by 360 times 13 squared, and that will find the answer in terms of pi. That will give you 28.16 pi meters squared. And then if you actually multiply that number by pi, you get 88.49 square meters. Today we are trying to find the area of the segment. The area of the segment is equal to the area of the sector. The whole area of the sector is like this big piece of pizza, minus the area of the triangle made by going from one end of the sector to the other. If you take the whole area, subtract this part, the triangle, you're going to be left with this part, which is the area of the segment. Make sure that you look at this and you can understand what I'm talking about. The whole pizza. Then you say, okay, if this is the whole area, that's like the whole piece of pizza, and you cut off the crust, you're left with a triangle. And then that triangle piece with the cheese and pepperoni and whatever the toppings are would be right here. And I want to know the area of the crust right here. So, find the area of this segment. We know that we take area of the sector minus the area of the triangle equals area of the segment. So first thing I'm going to do is find the sector. That's equal to pi times the radius squared times the measurement of the arc over 360. I have a radius of 10. So I plug that in. Measurements of the arc is equal to the same thing as the angle. What I see right here is that is 90 degrees. So that would be 90 degrees over 360. What you get if you don't multiply by pi is 25 pi. And I'm going to leave it in terms of pi. and that would be inches squared for the sector. Now I need to find the triangle. What I see, and I know that the area is equal to 1/2 times the base times the height. What I see is that since this is at a right angle, 10 can be the base, and since this length of 10 is the radius, we know that this height, this is another radius, is also 10. Any radius drawn in is going to be 10, no matter where I drew it. If I drew this segment, that would also be 10, so forth. So the area is equal to 1/2 times 10 times 10, which equals 50 square inches. The segment is equal to the sector, which is 25 pi, minus the triangle, 50. So you could leave it in terms of pi, 25 minus 50 square inches. Or you could actually multiply 25 by pi and then subtract 50. Equals 28.54. Square inches. Either answer will do. What about the area of this segment? So I see that I have a radius of 7. And then that means that this side is also 7. And it's the same deal. So first I have to realize that I take the area of the sector minus the area of the triangle. Having troubles here. Well, that's fun. Hopefully I can open this back up. Okay, well, I lost that. I guess let's restart. Here we go. So, starting with this one again, I have the area of the sector minus the area of the triangle equals the area of the segment. So, let's find the sector first. That's going to be pi times the radius squared times the measure of the arc over 360. Arc and the angle are going to have the same measurement, so this arc right here would also be 70 degrees. So pi times radius of 7 squared times the measurement of the arc, 70 over 360. Keep that in terms of pi. And I get 9.53 pi. Then the triangle. It's going to be 1/2 times base times height. Now, base and height have to be perpendicular. Do you see any segments that are perpendicular? No. If I draw it in, I could draw in a height, but it would be hard to find the height. And we know that the base, I guess, would be 7 also. But we can't find the height unless we use a bunch of trigonometry. But luckily, I have a formula that's going to help us out. Instead of using 1/2 times base times height, there's another formula for the area of the triangle. That is the area of a triangle given SAS. It is this formula right here. If you know two sides, we'll call them sides B and C, you know their lengths. And then you also know the measurement of the angle in between. So a side, an angle, and a side. If you know those three things, you can take 1/2 times the lengths of the two sides multiplied times the sine of the angle, whatever they give us. So that's what we're going to use on this previous slide. We're going to use 1/2 times side 1. We'll call, we'll just, instead of B and C, you can just call it side 1, side 2, times the sine of the angle. In this case, we have 1/2 times B and C are both going to be 7 times the sine of what angle? 70. Multiply all those out. You get 23.02. And then the segment, that equals the sector minus the triangle. So 9.53 pi minus 23.02. And you get 6.91, and if I had called this inches, would say square inches. Let's use it one more time. Right away I see that I have a circle with a radius of 6, which means that this radius is 6, and then if this is 120, this angle right there is 120. Okay, we find the segment, which is going to be pi r squared times the measure of the arc over 360. Leave that in terms of pi. Don't multiply by pi and you get 12 pi. Then let's find the area of that triangle, the unshaded triangle. Let's use that same formula, 1/2 times B times C times the sine of the angle. B and C are the two sides lengths. You get 15.59. And then the segment is equal to this sector. I should have said this was sector. I am sorry. Nope, I said it on the other ones. Segment is equal to the sector, which is 12 pi, minus the triangle, 15.59. Which equals 22.11 square centimeters. These two, 18 and 19, you can do on your own, doing the same method as we have been doing. But when we get to number 22, that's a little bit different. Now, what we see is that the sector that we are trying to do, we're trying to actually find the whole circle, subtract this sector, or segment, excuse me. So we don't want to include this. But instead of thinking of this as the whole circle area minus the segment, what if we think of it as this sector? So we'll just say it's the large sector plus this triangle. Either way will work if you think of it as circle, whole circle minus segment, or as a large sector plus a triangle. Either way will work. But I prefer to use this method because it's less steps. To find the area of the sector, that equals pi times the radius squared times the measurement of the arc over 360. We know it's going to be a radius of 18. Measurement of the arc. So we're talking about this arc now for this. What we see is that this is 90 degrees. So the rest of this angle would be 360 minus 90, which is 270. Right there, 270 degrees over 360. If you leave it in terms of pi, you will get 243 pi square feet. Next, the triangle's area is equal to, well, if this is 18, then this is also 18, and they're at right angles. When they're at right angles, you can use 1/2 times base times height. When they are not at right angles, that's when you have to use the sine times 1/2 times the two side lengths. So 1/2 base is 18, height would also be 18. And you get 162 square feet. Together, you have to add them. So you can leave it in terms of pi. This answer would be fine. Or if you want to multiply 243 times pi and then add 162, that's fine also. You will get 925.4 square feet. It's the same answer. Number 23 is done the same way. If you know that this arc, this angle is 120, the other side would be 360 minus 120, which is 240. You know you have a radius of 9, that helps. And then for the triangle area, you will have to use 1/2 times the two side lengths, which are 9 and 9, times the sine of your angle, which is 120. Next one, done the same way. 25. Find the area of the shaded region. Leave your answer in terms of pi and in simplest radical form. So what we see is a square with a side length of 2, which means that this side length is also 2, which means that the area of the square equals 2 times 2, multiply the side lengths, equals 4 square feet. Now, if this whole side length is 2, what would be the radius of the circle that fits right in that box? Well, it would be half of 2, which is 1. So the area of the triangle, area of the circle is equal to pi times the radius squared, which equals pi times 1 squared, which equals pi. What we see here is that the area of the shaded region is equal to the entire area of the square minus the entire area of the circle, I should say. It's what's left over outside of the circle. Well, if you subtract those, you'll have 4 minus pi, which in terms of pi, that is your answer. If I had asked you to not leave it in terms of pi, then you would actually multiply it out, or actually subtract it in the calculator. 4 minus pi equals 0.858. That would be feet squared. But we want it in terms of pi, so that's 4 minus pi feet squared. These are very similar. Realize that the box has dimensions, or the square has dimensions of 8 by 8. So you know you have to multiply those side lengths to get the area, and that the radius would be half of 8, which would be 4. And these two half circles create a full circle. (27) Done the same way. Realize that they gave us a length right here of 14, which means that the whole length of the square is double that. And then right here we have each one of these is a fourth of a circle. So together they make up one circle with a radius of 14 inches. Next, we went over geometric probability. With regular probability, we said that the probability of an event occurring is equal to the favorable outcomes divided by the possible outcomes. So if we said, what is the probability of rolling a 1 on a die? Well, how many sides have a 1 on it? There's only one side with a 1 on it. How many sides are there on a die? 6. What's the probability of rolling a 3 on a die? Well, there's only one side with a 3. So it'd be 1 out of 6 also. Same thing can happen with the length of a segment or with the area. So we can just say area of favored region divided by area of entire region. And that's what we're going to use next. So darts are thrown at each of the boards shown below. A dart hits the board at a random point. Judging by the appearances, find the probabilities that it will land in the shaded region. So what we see is that each of these triangles have equal area, and that the shaded region is just one of those areas, but there's total 4. So 1 shaded out of 4 total. Going to number 16, you say, all right, The shaded region is this circle, and we can say that it has a radius of 1. And the entire region is a big circle, and it has a radius of double that, so the whole radius would be 2. So the favored region would be area equals pi times radius squared, which equals pi times 1 squared. And the entire region would use the same area formula, but the radius would be 2. 1 squared is 1, times pi is just pi. 2 squared is 4, times pi. What happens to pi divided by pi is they cancel. So the real answer is 1/4. (17) you can do. You see they're all the same area. 18. What you see is that the shaded region is 360 minus 120, which is 240. So that would be 240 degrees out of the entire 360, which equals 2/3. Over here, you see this is 2/5. (19 and 20). These are a little bit more challenging. I expect you to try them. Number 23. This is very similar to what we ended 10.7 with. Dart hits each square dartboard at a random point. Find the probability that the dart lands inside a circle. Leave your answer in terms of pi. Okay, so we have side lengths on this square being 6. If the whole side length is 6, what would be the radius of that circle? Well, 3, right? So the probability is equal to the circle's area divided by the whole area of the square. Circle's area is pi times 3 squared. The square's area is 6 times 6, which is 36. 3 squared is 9, pi over 36. 9 over 36 is the same thing as 1/4, so that would be 1 pi over 4, or just pi over 4. That's the probability. (24) Try this before you watch this part of the video. If you tried it, now let's realize what we're doing. Okay, so what we have is a box with side length of 6, and then we have some circles inside. The circles, each diameter of the circle would be 3. See how it reaches half of 6? So that would be 3 also, which means that the radius of these circles would be half of 3 is 1.5. Now, the probability of landing in the blue is equal to the area of each of those circles, or of one of those circles, times 4, because there's 4 circles, divided by the area of the square. Now, the area of one of those circles is pi times the radius of 1.5 squared times 4, divided by the area of the box is 6 times 6, which is 36. 1.5 squared times 4 is 9. So we have 9 pi over 36. 9 over 36 simplifies to be 1/4, or 1 pi over 4, which is pi over 4. Go ahead to do the last one, and then do the problems. Try your best on these. These are ACT type problems, and we will discuss these in class. That is all of your homework, so print this out and follow along, or do it in your notebook. Good luck.